Okay. Once again, thanks folks for joining the session today. Today's session is going to be an introduction to machine learning. We are sort of going to learn about the concept of machine learning, where it sort of started from. We are going to learn about how it eventually connects to the sort of the thing that we are seeing right now, which is the large language models like ChatGPT, and how this field sort of evolved into what we are seeing in artificial intelligence right now. There will be a period where the session I'm going to do like a very high level technical overview for people who want to see how do you actually do machine learning at a code level. And then in the session, we are going to try and keep things very first principles. So we are going to try and explain the core mental models of how machine learning actually works. Okay, awesome. Now, a little bit about this group. This is a meetup community called Chill and Skill that me and my co-host Avneet, who is also here, run. The idea of this particular thing, which we call as AI Saturdays, is sort of like a weekly session where we pick up concepts and topics related to artificial intelligence. We sort of explain them in like a very practical first principles way. And we also sort of make this space, we want this space to be an open and a curious space. So it's for everybody, whether you are somebody who is a proficient in this AI or whether you are somebody who is a newbie. This space is for everyone. Ask questions, be curious. We want to create a sort of a low stakes, healthy learning environment. Now, the one thing I will mention is that it's important for all of us to make sure that this is a safe space to learn. And we understand that there's a lot going on in the world, and sometimes difficult emotions are high and there are difficult conversations. But this space is for everybody to learn together. So be respectful. Make sure that your tone is good. If it's not, if it is in any way harmful or offensive, my co-host and I are going to be removing those individuals or those messages. We really care about making this a healthy learning space, just with an open mind and a curious mind. And so that's something that I always sort of start with. Now, I'm gonna start off with a quick round of introduction of myself and my co-host, and then you folks can also introduce yourself. So my name is Madhav. My co-host Avneet is also here. We run an organization called Curious Skill, and this is basically a part of our meetup where we do these free learning sessions. We both come from technology and business backgrounds, and we are super excited to have you here. Now, I'm going to ask you folks to please introduce yourself if you can on chat. You can leave a message on Zoom chat and just quickly introduce yourself about what your name is, what do you do, and maybe one thing that you want to learn about today. So I'm going to give it 15 to 20 seconds or maybe a minute for people to quickly start introducing themselves, and then we'll go into the actual session. Thanks, Avneet, for getting us started with the introductions. I'm just going to give it maybe 30 more seconds, folks. Hey, Safai, I hope I'm pronouncing the name right. Hey, Master Degree in Health at Boston. Nice. Thanks for being here. Hey, Andre, uh, engineer, want to learn about intro to machine learning. Nice. And also Andre from history, and you want to learn the history of machine learning. That would be good. Hey, RP, thanks. Nice to have you here. Project manager, nice. This is going to be super interesting. I think there are a lot of things that came up over the time from project management. Hey, Donald, thanks for the introduction. Industrial capture and R&D, nice. And data automation pipelines, that's cool. I'm gonna give it 10 more seconds and then we'll get this going. Nice. Hey, Joanne. Montreal has a pretty good machine learning hub. I don't know if you're learning from the Montreal's Machine Learning Institute, but it's actually pretty good. Hey, Aurora, and hey, Chandu, nice to have you folks here. Nice. Uh, cool. We have a lot of cool folks, and thanks, and from different fields and backgrounds. And lovely to see all your introductions. Nice. Amazing job, folks. Keep the introductions coming. I am going to start the session itself. And folks, we will have time when I'm going to sort of ask for a break, and then I'm going to ask you folks to ask me questions. At that time, you can ask it on Zoom chat, or you can ask on Zoom chat anytime, or you can also use the raise hand emoji and I'll be able to answer that. Okay, awesome. So these are the six things that we are going to cover. We are going to look at what machine learning is, where does the concept come from. We're going to look at how what does it mean to learn from data. That's a key part of machine learning. We're going to learn about what a model is. We will do some math and we are going to look at some code. You don't need to understand everything, but just to get the basic mental models in. And then we are going to actually make a connection from all of this to where we are right now in ChatGPT and other large language models. Okay. Let's start with the basic thing of where all of this started. And this sort of started like many, many decades ago. If somebody has seen that movie, The Imitation Game, that's one of the earliest points of when we started to think about this idea that can we have machines do complex tasks? Oftentimes, tasks that might take a human a long time or tasks that were typically done by humans. And so, like, the starting question that started the idea of machine learning was that we want the machines to be able to do what people do. Now, the idea was that we were building these initially mechanical machines, then digital machines, which essentially were able to do amazing things very fast. And the idea was how do we actually make the machines sort of like do a lot of the work? How do we automate that? And how do you sort of ask them to do things that humans are able to do? Now, when we started doing that, there were two kinds of different things that we could ask the machine to do. There were the deterministic things. A deterministic thing can be, let's say, asking a machine to take a thing from point A to point B, asking a machine to maybe do mathematical calculations, making a machine run like a calculator, making a machine do stock analysis. So that was one of the earlier sort of deterministic things that we could tell the machine to do. Then there was also the things that are not so deterministic. So the most common example that I take is that as people, let's say, if we do have eyesight, if we look at a cat and a dog, we will be easily able to differentiate that. We will mostly be able to tell that this is a cat, this is a dog, because our brains have sort of learned to pick up on the cues of how the objects are looking to sort of categorize them. Similarly, humans can do other things. We can read a handwriting. We can translate a sentence. We can sometimes look if something is off in a payment. We can answer a question in plain English. All of those things are less deterministic, but more of things that we have learned over time. And obviously, when I say we, what I mean is like our brains have learned over time through school, through experience, through people around us, through all our engagements around us. Now, this is the real challenge that came that how do you make machines do these sort of like, if I have to use the technical term, stochastic tasks or probabilistic tasks, or tasks which can't be defined by a simple, like a recipe to cook something. And how do you sort of like make the machines do that? Now, that was the trickiness there, where how do you sort of get the machines sort of learn those things? Now, at that time, this idea sort of started to take hold that we as humans, right, we learn by looking at examples of different things. We sort of read textbooks to learn about the world, about how to write, about mathematics, about so many different things. And so this sort of idea started to shape hold that how do we make the machines learn, hence the term machine learning, from examples? Like, how do we, let's say, if I want a machine to be able to tell me whether something is a cat or whether something is a dog, how do I give it like, how many examples of those images should I give to a machine so that the machine is actually able to learn the same thing? Now, I'll give a very practical example of this entire thing. One of the most earliest things that we taught the machines to learn, especially in the internet era, was of detecting spam of your emails. Now, when you have an email right now, most of the time the machine is actually able to categorize it as spam and not spam. It's very hard to write rules of what a spam is. So, to teach the machine, we had to give the system a lot of examples of spam and not spam emails, and then tell it that, okay, this is a spam, this is not a spam. And then that is what enabled the machine to actually be like, okay, now I can recognize, and now you get that for free on your Gmail. Sometimes when you go and you look at spam and you find an email from a friend that was actually not a spam, and when you mark it not a spam, what happens is it actually goes back to that machine and the machine learns from it that, okay, this was actually not a spam, and then it changes its understanding. So the idea of machine learning came from this idea that how do we give data to the machine so that it is actually able to learn patterns from it, and then it's able to do things that human brain is oftentimes capable of doing. Now, we are going to now quickly talk about what does learning from data mean. But before I go there, I am going to pause at this point, folks, because I know that there's a lot of information. Any questions, folks, till this point? If there are, you can use your raise hand emoji or ask on Zoom chat and I can help. I'll give it 10 seconds. Okay, awesome. So now the second part then that came is like, okay, we have this ounces of data. Like, okay, let's say I want the machine to learn whether something is a cat or something is a dog. But how would that happen? Yes, I can collect hundreds of images of cats and dogs, but how does the machine actually like learn something? Like, how does it know that? How does it like internally, like, what's the act of learning means in a machine? It's even hard for a human to sort of explain sometimes what does learning mean, but we have to quantify how does it actually learn. Now, that's when we sort of looked at two different kinds of learning. The technical terms of these learnings are supervised learning and unsupervised learning, but I'm going to call them something like sort of differently. One of them I'm going to call as like more deterministic, I already know the answer learning, versus the unsupervised one is more exploratory. I'll sort of explain what that means. So in supervised learning, what you do is you give machines a lot of data and you already know. Let's say I'm telling the machine to identify whether something is a cat or something is a dog. So I'm already going to give it images and I'm going to give it the right data. I'm going to say this is a cat, this is a dog. So the answer is already known. And then the machine learns from that data. And then in the future, if I give it a different cat image, it can say that, okay, this is a cat. So in supervised thing, the answer and the examples are already fully defined, and then the machine just has to sort of learn through that. Now, unsupervised learning is very interesting. In unsupervised learning, or what I say as exploratory learning, the machine is just given data, a lot of data, and then it has to find random patterns in that data. So I'll give a very realistic example of it. Sometimes we do something known as a heat map of a thing, where we sort of show that, okay, everything between 10 to 20 years old is green, everything between 20 to 30 years old is red, and then sometimes when we look at all the data together on a graph, we can start to, as humans, see patterns that, okay, this group of age is here, this group of age is somewhere here. And that's sort of what I call as an exploratory learning. And so that's in unsupervised learning, that's what happens. The data doesn't have any labels. So machine doesn't know what is a spam, what is not a spam. And let's say the machine sort of figures it out, patterns from the data, and that can sometimes yield to things that we have not even thought of. So unsupervised learning is more like exploratory in that nature, whereas like supervised learning is more like when you already know what the data set is, and then you use it for making predictions such as whether something is a spam or not a spam, or making a prediction such as if somebody has done two undergraduate degrees, what's the prediction, what is their predicted salary versus somebody who has only done high school education. So all of that stuff comes from supervised, and then unsupervised is more exploratory. Now, here is where like the concept of the model comes in. Um, Okay, I have a question. Identifying traffic lights out of multiple images, which we will run. So, identifying traffic lights is supervised because if a machine has to identify lights, you have to show it what a traffic light is and what are other kinds of lights are, and then you have to tell it that this was a traffic light, this was not, so that it can get that data. So, if a machine is doing it, then that would come under supervised learning. Okay, now and folks, we are going to pause sort of a couple of slides to answer some questions. Now, let's say let's say you want to have like you want the machine to be able to identify cats and dogs. And now, folks, you will see me sort of go to a different screen. So let's open my Xkelly draw and we are going to see something here. Let's say I have a machine. Okay. Let's call it the machine just for the sake of it. And let's say in this machine, the purpose of this machine is to identify cats and dogs in images. Let's say that's the purpose. Now, let's say I have a million cats and dogs. Let's say I have 1 million images of all kinds of cats. And I'll sort of like show you actual examples. And let's say I have 1 million images of all kinds of dogs. And now what I want to happen is, sorry, my handwriting, let's just select this. I'm going to create a bit of a gap. Now, let's say this is the information that I'm feeding to the machine. Now, what the machine needs to do is it needs to look at, and when I say the machine, folks, it's essentially your computer. So it's your laptop, it's your computer, it's a server, it's anything that is essentially like a computing machine. Now, when this machine sort of looks at these images, it has to somehow learn those patterns and create an internal representation, let's say here, and we'll go into the specifics of it. It needs to create an internal representation of what a cat looks like and what a dog looks like. So essentially, when a machine is given all that amount of data, it has to using a learning algorithm, and we are going to sort of talk about that very second in a second. It has to create an internal representation, just like in our brains, there is a representation of what a hand looks like, what a face looks like. The computer also needs to do that. Now, that is what is known as an AI or a machine learning model. Essentially, once the machine has sort of learned the data from all these different cats and dogs images, it creates what is known as a model. And that model is what has an internal representation of this data, which can then allow it to, let's say, classify a new image as cat or a dog. Now, I'll give a very funky thing that is actually being discussed in like neuroscience side. Like when let's say a child is born, we are born with a brain. You can sort of imagine that like our brain is already pre-built with certain models. Our brain can recognize faces. A child's brain can recognize sounds. So think of them as models that the mental neurons have sort of built. They have an internal representation of what is sound and what is someone's face. That's the same thing we want a machine to have or a computer to have. We want it to have an internal representation of cats and dogs. And then once it has that, that is what we call as a model. Now, if I go back to my slides, that's what it is representing. Now we have the data. Then the machine sort of captures the rules and the patterns of that data. It creates a model for itself. And then that model is what it uses to do things. So let's say if I have a cat and dog classifier, that will help to identify whether something is a cat or something is a dog. Another model, it might be used to generate text. That is the model that you are using when you are using ChatGPT or when you are using Claude. Because what we did was we gave it a lot of language data. The machine learned the patterns of human languages, and now it seems like it's able to talk like humans as well. So that's always the foundational thing. You give it data. Now you're using that data, it creates an internal representation, and then it's able to spit out the different tasks that it is supposed to do. Now, I am going to pause myself again here, folks. Any questions? You can either raise your hand or you can ask it on Zoom chat as well. I'm going to give it at least a couple of minutes because I know like this is complex. Okay, we have one person. I'm going to unmute you. Hey, Arby.
Thank you. So I just want to get some understanding. Machine learning started off with visual models to learn from, but it can also learn from non-visual models. Is that correct?
I would actually say the opposite. When originally machine learning only learned from text data,
Oh,
like
okay.
And but it's only very, I would say, now when we have the capability to have such high quality images that it is
Mhm.
learning visual things. But the original machine learning that was done many, many decades ago, it was just to like the one of the first applications was identifying sentiment of a text. So
Mhm.
it would tell whether somebody's message is a happy message or a sad message or an angry message. So that was one of the earliest implementations. So it used to be a lot of text data, then it slowly became audio, and then as it progressed, now it has visual and a lot of components.
I see. Okay. Thank you for confirming that. I appreciate it.
Yeah. Okay, awesome. What would happen to a model if there is an image input that has a mix of a cat and dog? That's a great question, Andre. And my answer to that would be it depends on how the model has been trained. So, depends on how the model works. If the model is just a pure classifier, which is whether it's a cat or a dog with 100% certainty, there is a chance that whatever it says is not entirely correct because the image has both. But if it's a model is probabilistic, where rather than saying that it's entirely a cat or entirely a dog, let's say the model sort of like tells it's 60% cat, 40% dog. So that model might give you a more accurate response. And that's where learning algorithms, which I'm going to talk about next, come into the picture because there are 100 different ways to make this model. But depending on your use case, you make them differently. Let me know if I answered your question, Andre. Amazing question, though. Great questions, folks. I'm gonna like give it maybe a minute more for people to maybe ask more questions. Otherwise, we'll move on to the next part. Okay, awesome. I don't see any questions. Now, now this is the part where it sort of becomes interesting. Which is very, very like which is the part that I haven't really talked about. ML and ChatGPT. Oh, okay. I'm gonna answer that question before that. Okay. So let's go back to my not so pretty Excel draw. Okay. So remember we looked at this. We looked at the if the purpose of the machine is to identify cats and dogs, we give it a lot of data, right? And then the machine learns an internal representation and then you get an ML model. Okay. Now imagine the purpose of the machine was different. The purpose of the machine was to generate human readable and logical text. Let's say that is the purpose of the computer that the model that you are building. To do that, the data that let's say if I fed the machine a data, which is all human generated text that is available. Let's say I did that. And that data is then used to create an internal representation of human language and let's say even reasoning. And then let me just increase this. That model is what right now you are seeing is what is ChatGPT, or rather, the more accurate would be GPT model. Again, the concept is the same. This is how ChatGPT was built. All human readable generated text was given as data. Then the machine created an internal representation of that data and it was able to learn about human language and reasoning. And then you got something like ChatGPT, which is able to do that. So that is the relationship. Machine learning is sort of the engineering principle of how do you build these models. ChatGPT is an example of a model that got built very recently that has a purpose and that's used for conversations essentially. Let me know if I answered your question, but this was a great question. Okay, feel free to ask me a follow-up, but that's the relationship. Okay, awesome. Now, this is the part where well, this is not the only part, but this is a big part of where the actual magic happens. Where how do you how does a machine like a computer learn from the data, right? Again, if you show me over and over images of cats and dogs, or if you show me spam and not spam messages, even my human brain will get used to like what is a spam and what is not a spam. But that's because we have certain analytical thinking and all of those skills. But how do you make a computer sort of do that? Now, this spawned, and I'm gonna like go back here, and we are gonna like now talk a little bit more about this. This particular problem spawned a huge set of what are known as machine learning algorithms, and I'm gonna talk about one in depth. I'm gonna but show you though how this actually works. So this spawned an entire branch of machine learning algorithms, which basically used, and I'm gonna like put it here as concepts, concepts of linear algebra, concepts of probability, and concepts of statistics. So a lot of this is coming from math, um, to basically make the machine learn from data. So there are like a lot of different algorithms that exist. I'm going to show you one of the simpler ones that you might have heard of. But some of the more popular ones that you hear of is there is regression. That is one. There is something, and again, folks, you don't need to know what it is, but I'm sort of giving you like words. So there is something known as like k-means clustering. Recently, you are using GPT, right? So GPT is a learning algorithm. The T in it basically means transformers. And basically, transformers is a machine learning mechanism that allows the machine to do this, which is learn from human language. So there is like many machine learning algorithms. If you go to the Google right now and you write machine learning algorithms cheat sheet maybe, and then you can see resources like this where like you can see a lot of different kinds of machine learning algorithms. Regression is one of them. There is clustering. There is like many algorithms. Another example is, I'm assuming people here use Netflix. On Netflix, you get like a recommendation. This is the next movie you should watch. This is the on Spotify, you get a recommendation of this is the music you might like. All of those are built through different ways of making the machine learn about your taste and then giving you recommendations. And so there are many algorithms. You might, depending on what you are trying to do, you might sort of encounter specific ones. Now, all of those algorithms essentially uh, sort of have a very similar structure, which is essentially this. Okay, between ML and AI. Thao, what I'm going to do is let me finish my current thing so that I don't lose my chain of thought, and then I'll answer your question. So just give me 2 minutes. Okay, so uh, going back now, all of these algorithms usually have the basic structure set up like this. And folks, this is going to get a little technical. So I'm going to give people a little bit of time. I'll also show you how it looks, but you like as long as you understand broadly, it's fine. So the way it sort of works is, and this is how most of these algorithms work. Let's say I have 5 cat and dog pictures. Let's say this is cat one. I'm just going to like copy paste this. So let's not call it cat one. Let's call it a cat. Let's call this another cat. Let's call this another cat. And let's say I have 1, 2, 3, 4, 5 dog pictures, right? And I'm just gonna give a very simple, like a very basic simplification of what I'm trying to say. Obviously, like it's a little bit more complex than this. And let's go here and let's go here. Okay, so the way it sort of works is the way all of these algorithms work is, let's say if I am the machine, right? I am this machine here. I will start with a guess. Okay, so what's going to happen is I'm going to look at an image and I'm going to say, oh, this is a cat. Now, we are going to give it feedback that no, this wasn't a cat, this was actually a dog. And then machine internally configures itself, and you don't need to know how. It configures itself into, oh, okay, this is actually a dog, and then it learns from it. So all the machine learning algorithms sort of start with this like a very basic system. Let me just go back here on the slides where they sort of predict something. They predict that, okay, this is a cat, this is a spam, this is how a human might talk. Then they internally measure that is this actually how it looks in that data. Then they adjust their internal brain and then they keep doing it unless it reaches a good space of a model. You can sort of think of it like, you know, how when you are a child, when you are learning something new, you sometimes learn by answering a question, then somebody corrects you that no, this is not exactly, and then you are like, oh, this is not, maybe then I'll try something else. So that's the same concept with machines. They basically start off with sort of a broad guess. Then they check the guess with actual data. If the guess is wrong, they sort of change their internal representation. And once they keep doing it over and over, they are able to reach a good place where they have a good internal representation of, let's say, what's a spam and not a spam. So this is a very key point. Learning is repeated error correction, which is why when I always say this, when you go to your spam, let's say on Gmail, and you select something as not as spam, that you are correcting the error of the machine's AI model. Because then it knows that, oh, I said it is this, but the human is telling me it's not. And so I need to change my internal representation. So the concept is that it's always repeated error correction, and that's why you need that much amount of data because it starts making errors, and then over time we want it to be like 90% accurate, even if it starts from like 50% accurate in the beginning. Now, uh, I'm going to answer both the questions. Can you explain the difference between ML and AI? For sure. So artificial intelligence, okay, maybe a diagram will help because this might make it a little easier. A great question though, by the way. Artificial intelligence is, but what's the purpose of artificial intelligence, right? You want machines to do human intelligent tasks. Okay. Now, what I'm about to say, not everybody agrees in the same way of looking at it. So you can take it with like 60% accuracy. But this is how I would explain the difference. This can be done in two different ways. One way is what I said in the beginning, deterministic programming. You are writing the actual code and the machine does exactly what you write. And then you have the other end, which is learning based intelligence. Now, this is basically what machine learning is. So, machine learning is a subset of artificial intelligence. It's artificial because it's not human, it's a digital machine. Technically, programming, which is just purely writing code and the machine executes this, is also under AI. But mostly people associate machine learning with artificial intelligence. Essentially, a machine learning is needed to make an artificial system intelligent. I'll give very, very simple example of it. Let's say you have a robot. Okay. Let's assume a robot is an artificial system and you want to give it intelligence. Now, inside that robot, you might have multiple different abilities. It can find cats and dogs. Let's stick to that. It can lift things. So let's say I focus on these two things. My handwriting is bad. Sorry, folks. Now, all of these will be different machine learning models. So this might be model one that allows the robot to do this. This might be model two. So they all might be using different machine learning techniques. But machine learning is what you use if you want your machine to sort of become intelligent and by learning from data. So that's how AI and the machine sort of connect with each other. Let me know if I answered your question, Thao. Okay, I have another amazing question from Jamal. How does machine uh, correct for error if human is not telling them? So here's the thing though, you don't always need humans to tell it, right? When you have this sort of a data where you already know whether something was a cat and something was a dog, and when the machine learns for the first time, so you can just tell it by programming that, oh, you said it's a dog, but it's actually a cat. So you don't really need the human intervention. Having said that, once you have built the initial brain of the machine, after that, let's say the machine said that, oh, this was a cat when it was actually a dog. At that time, when the human gives that information, that can flow back into the machine to improve its model. So you don't need that for the initial model. You can actually go pretty far in the initial model because we have access of ounces of data. There is ethical concerns. I'm not going into that rabbit hole. But we have access to a lot of data. So you can build the first model, but after that, once you give it to a human to try it, then the human feedback can sort of flow back into the machine. This entire concept is also known as reinforcement learning, which is like after you have built the initial brain, you can sort of give back the response to it. Jamal, let me know if I answered your question. And folks, if I haven't answered, just let me know. I can make sure I can reply. This space is for you folks. What about agentic AI, machine learning different? Great question. Uh, Agentic AI is a, let's say, implementation of AI which uses machine learned systems. So, what I mean by that is when you have an AI agent, let's say like this, any AI agent, whether you are using ChatGPT or whether you are doing something else, in the background, it will use a model which was built from machine learning. So, an AI agent uses a model which has been built via machine learning. So, an AI agent is an artificial intelligence system, but the difference is that an AI agent essentially has a model that it uses, but that model is built from machine learning. So, they are all sort of intertwined. Agentic AI is like the final product that you build, but in the background, it's built using machine learning. Let me know, Peter, if I answered your question. Amazing questions, folks, because like all of these terms are sort of like thrown around quite a bit. Okay, awesome, awesome. I'm gonna just give it 10 more seconds. Private data on which the machine is supposed to learn are biased. That's a great question, and that is where you run into issues a lot of times. If the data that you are given, let's go back to the cats and dogs example. Let's say I had a bias. I'm not a cat or a dog owner, so I don't know if this is right. But let's say all my images are of only one type of cat in different positions and stuff. Then my model is going to be biased to only being able to recognize that. So one of the very active fields in machine learning for decades now, but more recently with ChatGPT, is how can you get a wide variety of data. Now, if there is a math person in the room, in statistics, there is a concept of sort of creating a distribution of data that's very like independent and has a lot of diversity. So there's a lot of mathematical ways that you can test whether your data is biased or not. But basically, if your data is biased, then the model will be biased. It's no different from me as a human. If I only know how to drive, if I only keep driving a manual car, like a manual shift car, as soon as I get an automatic, it's gonna sort of, I'll make mistakes in that. So that's the same with these models. If the data is not spread out, then they will be biased, and then that can lead, like there have been court cases because of it, because there was a model that was deployed in the US somewhere, and that model was supposed to identify, I think, like certain potential criminals and stuff, and there was a very heavy bias against a group of folks who were like who are more incarcerated, and then that led to it like categorizing unnecessary people. And so there have been court cases on it. That's the entire idea of making your model public, so that you can identify the bias as a person who is using those models, so that you can know like what are the mistakes that the model can make. Let me know, Zoom user, if I answered your question. How do you determine when the accuracy of a model is good enough? How long should you keep on tweaking it? My honest answer, Kunal, is if you can afford it or if you have the time, your model should always be tweaked. The reason for that is, yes, you can test. So what you can do is, I'll talk more about this in the end, but let's say you have a data of 100 cats and dogs. You use 80 of that data to make the machine learn. So that's your training data. And then you have a test data that you test against. You should always be updating your test data, and you need to keep checking your model against it, because it very rarely will you be able to get all different kinds of data. So the more people use your model, the more they can give feedback. If you look at ChatGPT, it asks for feedback sometimes. Was this the right kind of response? Because it then feeds it back to the model. So it depends on your use case. Maybe, like, for example, it's something that's not that high stakes. So maybe like a 90% accuracy, you can continue. But let's say you have a machine learning model that's detecting cancers by looking at lung x-rays. So that's not something that will ever be one and done. You will have to keep updating that as hospitals, as medical professionals learn different ways of detecting cancer. So you will always have to sort of keep growing that. It's always an evolving thing. Let me know, Kunal, if I answer your question. Okay, I'm going to assume double exclamation marks is like it's a happy double exclamation mark. So all good. But folks, keep the questions going because it's really great and I think everybody learns from each other. Okay, awesome. Cool. Now, like I said, we have many different ways to learn data, and there are many different ways for a machine. If I go back to here, to sort of like do an internal representation. Where was my diagram? Somewhere I wrote. Let's see. Okay, either way, there are many different, yeah, here. There are many different representations, ways for a machine to internally represent the knowledge that it has learned. Now, there will be a little bit of math, folks. I'm gonna like, the math is not important. I wanna just explain one of the algorithms just so that you can see what that actually means. And just to get a basic idea of it, you don't need to like sort of understand the math fully. Regression is one such model. So regression is the oldest form of like machine learning, you can call it, but it's statistics, it's used in economics, it's used all over the place. If somebody here who has studied that, they will probably know more about the maths than I do. But as a programmer, I can sort of talk at a high level about it. So uh, let's say what a regression essentially does is, let's say you want your machine, when it is given some input, you want it to sort of create and you want it to be able to predict the output. Now, in our high school math, we learn about this concept, and I'm gonna like go here. Here, I'm gonna call it regression. And let's say we learn about this concept of y is equal to mx plus b, which basically means that you want to calculate the value of y based on the value of x and a constant b. Now, in machine learning terms, what you want, let's say, a machine to do is to actually, let's say my x is my current education level. Let's call it that. But let me use the example that I have here. I forget what I was using. Okay, yeah, let's say I'm going to increase the size a little bit. Rather than calling it my education level, my X is how many hours I studied. And then, sorry for my handwriting, I'm going to just make it a little bigger. Dun, dun, dun. And folks, the math will end soon. I just want to give an example. And the Y is how much did I score? Now, let's say what I want a machine to be able to do is, if I tell it how many hours I studied, I want the machine to learn and tell me how much will I score. I want it to be able to predict. Now, in the machine learning world, what you would then do is you would first find loads and loads of data. So let's say you're going to find loads and loads of data. That's going to say that if X is 10 hours, then Y is, let's say, 15. Then when X is 20 hours, then Y is 30. Let's say, broadly speaking, what's going to happen is that as I increase X, my Y is also increasing, which is my Y is the how much will I score. So let's say I want a machine to learn that from existing data set so that it can help me predict how much will I actually score based on the number of hours I will study. Now, to do that, what we need essentially the machine to figure out after looking at this loads and loads of data is to figure out the value of M and to figure out the value of B. Now, this concept is what is known as regression, where what the machine does. Remember, we sort of talked about this idea, right? That the machine is constantly going to improve and reduce its error. So what the machine does is it sort of starts with a value of M and a value of B. It then takes this as an input. It checks that, oh, my error was, let's say, 15. Let me tweak my values so that my error reduces. And so it will keep going over and over until it can find and learn the right values of M and B from this data. Once it has, then I can plug in my value. I can say like I'm going to study 5 hours, but then I can get how much score I'm going to get. Now, again, no need to go into the full math of it, but the idea is this M and B is the internal representation that the machine has made from this data. And now it's going to use it to actually help me with my prediction. For folks who are a little bit more aware of what this means, it essentially means like if this is your data, are studied and exam score, and if you show it on a graph, it essentially is about finding this line that connects all of that data. And then it won't be exact, but it will be close enough. And then you can use this line to then predict what my score will be if I, let's say, study 5 hours. Now, this is the idea of the machine learning internal representations. In the case of what I have just shown you, known as linear regression, it's just the value of this m and b. But your equation could have been way more complex. It could have been something like, let's say, mx square and let's say cx to the power 4 plus dx to the power 7 minus ex to the power 2, and let's say some constants, let's call it q. So your equation could have been way complex. It won't look like a straight line. It would be like way more wonky and way more parabolic or whatever higher orders are. And then the machine can even learn something as complex as this as well. Now, this is an example, one of the oldest examples that is now used in machine learning. When you want the machine to learn patterns from data using an equation like this, there are 100 other ways of learning the same pattern. I may not have used this equation at all. I may have used something very different. But essentially, the concept is essentially the same. The machine is going to start with some random values of its internal representation, which was m and b, and then it will keep trying to minimize the error, and then eventually it's able to find like something that's close enough, and that can give you a value of a score. Now, this is what essentially happens. You give the data, a model is built using the learning, and then you can use that model to then predict. So I can put in my value of, okay, this is the amount of hours I sort of studied, and then I can sort of predict what my score would be. Uh, Fun note, linear regression and regression in general, something like this, can be used to teach the machines how to predict what the value of a stock might be. A lot of these algorithms are also used in futures and options trading. There's an entire mathematical algorithm that is built in that side of the spectrum as well. But essentially, the concept is the same. You have an internal model that you want the machine to learn, and then you learn it by reducing the error in the machine's answers. Okay. Now, I'm gonna go here. I'm gonna pause now. I know this was a bit more math that people mostly like, but I still wanted to explain that. Any questions, folks? I'm gonna give it maybe a minute. You can raise your hand or you can ask it on Zoom chat. Okay, awesome. Now, now when I showed you this model, right? And folks, if you have any questions at any time, you can like keep asking, but I'll sort of move on, but keep asking me on Zoom chat. But when I showed you this model, now this, let's say I know the values of M and C and D and E. So that is what becomes the model for the machine. Now, this is a very complex model that you need to build over a large amount of data. But in terms of the history of machine learning, this is what is known as a simpler model. The reason for that is the algorithms for this are known. How the machine learns is also very deterministic. So these are some of the oldest models. So these are quote unquote simple, but they are not simple, but they are just like more known. Now, built on this came the concept of neural networks. I'm just going to talk a little bit about it, but that will be a separate session. Neural networks are a way for a machine to learn things by simulating how our brain learns. So there is a Canadian physicist, I forget, Geoffrey Hinton, who came up with this learning algorithm for a machine where he sort of created a sort of a model which looks like our brains and neurons, and then those neurons learn from data. So they are sort of digital neurons. So neural networks was the next thing that got built. Neural networks are a lot more powerful and they can work with a lot more complex data, mostly because they are modeled after our brains, and so they are able to capture the complexity of our brains. Now, then once neural networks, they started in the 1980s, I think till 2010-ish, that was the gold standard. Then came deep learning. In deep learning, you sort of stack neural network over neural network. So like you build one model, then another model on top of it. So it just sort of like keeps going. It basically we are just trying to sort of recreate the complexity of how our human brains sort of work. So deep learning sort of goes further, like it's able to identify things such as, oh, it can find a cat in a room full of many cats and dogs and people. So deep learning uses even more amount of data, has a much more complex learning algorithm. Deep learning is what has given us ChatGPT. So the simple models, they could never really create something that could help you predict the next word, like just like ChatGPT does. Neural networks were kind of able to do it. So you have older language models that are able to sort of work like that. And then deep learning is the one that truly broke through recently, which is able to actually learn the English grammar or just the grammar of languages. And then you are able to sort of see then you're able to see like the human like ChatGPT interactions. Now, I will say though that if you are somebody who wants to really learn this, you do start at the simple models, because the first thing is to sort of understand that you are teaching the machine how to learn, and then you can sort of start to build on top. That is how actually ChatGPT was built. Initially, it was given a huge amount of text answers and it was asked to predict what the next word would be. It was also shown some good answers and bad answers. And then it was also shown what people might. So every time, like when you rate an answer from ChatGPT or Claude, it's given back so that it can learn better. And then using deep learning algorithms, it was able to learn from all of that data. And then again, concept is the same. It first guesses the wrong word and then we correct it and then it guesses the right word. But the deep learning is then able to like help it sort of learn chat GPT over that. And that's how like all sort of models are built. You have the data, you build a model, and then you keep adjusting the error, and that's almost like a lifelong thing. Now, I do want to show you what it actually looks like to build a model like this. But before I go there, I'm going to pause, folks. Any questions or thoughts? Or any questions on Zoom chat? You can also do your raise hand emoji, and I can help with that. Oh, okay, we have one question. Hey, go for it.
Yes. Since machine learning is able to learn and is learning, why is it that some of the companies are asking us to train the AI?
Mostly because I mean also like don't mute yourself because I'll have to unmute you again. So let me finish and then you can let me know if that's correct. Like that answers your question. But the
Okay.
thing is the deep learning models, right? These ones. One of the
Hmm.
things that we learned by applying them, that the more data you can give them, the better they get. Like I know it's an oversimplification, but essentially the more variety of data you give them, the better they get. So let's say, for example, I'm an owner of something GPT and I built my first model, and I realized that this model is really bad at writing songs. So for doing that, for adding that, I need to give it a lot of data of how do people write songs. And then that's where I would bring in those people who would help train that. So the more variety of data you can give in deep learning, the better it can get. And the point is that we are sort of exhausting the amount of data that's already there. On the internet, they have scraped everything. They have scraped everything from books. There are legal issues
Hmm.
to it. So now they
Hmm.
need more data, and that's why then you need the humans to generate that data.
Okay. All right. I see. So it'll be almost like an ongoing process from now until man doesn't exist anymore, so to speak.
Yeah. Yeah, yeah, yeah. I can give a very like interesting example. I mean, it's sort of sadish, but kind of interesting that in India, I'm from India, so like there are companies who have now head mounted a camera on the people who weave cloth, so that eventually that data can be used as videos for a machine learning algorithm to build a robot that can do the same thing. And so like it's sort of like it'll depending on which complex task we want the machine to learn, we'll need more and more of such data.
Wow. Okay. All right. And thanks for giving that example. I appreciate. You can put me back on mute. Thank
Oh
you.
yeah, okay. You can do that yourself. You can't unmute yourself, so that's what I have to do. All
Okay.
Are there any more advanced algorithm researchers are looking out to develop beyond deep learning? Maybe, I don't know. I think, again, I'm not an expert on that side of things in terms of the research side. I'm assuming there will be something. I know that there have been some experiments in something known as biomechanical learning, where what they did was, I don't know if people know about this, but recently they took a bee, like a bee that stings bee. They created a map of their brain, and they recreated that map as biological tissue in a lab, and then they made that tissue learn things, like it was able to identify the same things that a real bee can do. So there is like a bio algorithm side. There is also quantum learning, which is its own sort of a side field. So I'm assuming there are a lot of researchers who are continuing to do stuff on it. Are limitations in modeling outcomes with mathematics the reason for GPTs getting in circles with outputs? Yes, 100%. Because all of this is stochastic, it's probabilistic. That is one of the reasons. Because again, what I'm about to say, sometimes people don't agree, but it is sort of true that ChatGPT is not intelligent in the human sense. It's a word prediction machine which is using math to predict the next word. So anytime, like any errors that it has incurred in its model, you will see those errors. And once it starts going down an error loop, it sort of feeds over itself. But because it's sort of a mathematical model, that's why like it has a certain accuracy, and that's why it runs into issues. Let me know, Peter, if I answered your question. Donald. Meta has half their engineers writing code examples for training. Yep, exactly. Even in my company where I work full time, we are using Claude Code for a lot of our work. I'm pretty sure Claude itself is learning from our coding to make their model better. So like that's just the way it is with these models. Can you briefly explain quantum? I really can't. I just use that term because I know about it from somewhere I read. I have no idea how quantum computing or like quantum learning or any of that works. So I won't be able to, but I'm sure like there are resources available for that. Okay, awesome. Keep the questions going, folks. I do want to give a little folks a little bit of a flavor of what it means to sort of build a model, just so that they know, like when people say they are building a machine learning model or a deep learning model, what it actually looks like. So I'm gonna go here, but folks, keep your question going. I'm gonna go to my Excalibur first. All right. Okay. So when you are building a model, okay, building a model, there are a few things that you need to understand. The first thing is building a model essentially means you need to have a data set. That's the first thing that you need. You need a data set because that data set is the thing that the machine is going to learn on. Then let's go back here. You need to have a learning algorithm that is going to learn from that data. So I'm just gonna just point it. Data set is fed into the learning algorithm. And then let's increase this here. For this learning algorithm to work, you need hardware. You need the actual electronics for the learning algorithm to learn. So, I'll give a very dumb example. I know people might have observed that the GPU prices have shot through the roof. The reason for that is, and this is the reason why everybody is sort of talking about it, when you are building a language model like ChatGPT, which uses a lot of human data set, using the transformer learning algorithm. That's what the T stands for. If we do it with our normal CPUs, it's gonna take us like, I don't know, hundreds of years, but tens of years to finish. That's why you need specialized hardware called GPUs, which are a lot faster. They are able to do a lot of things together. And that's one of the reasons why GPUs and all of these prices have gone through the roof, because you need those data. So when they are saying that they are building an AI data center, essentially this hardware is being built so that they can apply a learning algorithm on a huge data set, and it can be done in a reasonable time. Like it can be done in like 6 months. And 6 months is a reasonable time. It takes like an algorithm 6 months to like sort of actually learn something sometimes. And so that's where the hardware comes in. So you need the hardware, right? And then once you have the model, let's say you have built this model, right? That's when you actually have to store the model somewhere. So you also need storage for it. It's also one of the reasons why like the storage costs have gone out of the room, because you need storage. So the model needs storage, that somewhere it has to be stored on some system that somebody can access. And then from there, you build your final product on top of it, like what you want the model to do, what its use cases, and whatever. So you need all of this, all of these different things. Now, for you to make sure that the machine is actually doing something, right? The machine is actually learning and it's actually like doing and it's actually building a model. You need a programming language because programming languages are the way for you to tell the machine that, okay, use this learning algorithm, use this data set, give me a model, and then that model I'm going to use. So that's where it all sort of intersects. The concept is this, but you need for making a machine do it, you need a programming language that's going to talk to the machine to make it learn, to manage the model, to manage the storage, to manage all of this infrastructure. Now, I'm going to give you an example of Python and how it is done in Python. Python is a programming language, folks. It's used for talking to the systems. You don't need to know Python. I'll just show you very briefly of what I am essentially doing in that. So Python is the programming language that will help us do all of this. Python is what we are going to do is we are going to have a data set, we are going to have a learning algorithm, and that eventually you are going to get a model. Now, let's see the code. And folks, it's okay if this doesn't make sense. I'll be sharing this code on GitHub with you guys later as well, but just so that you understand what this is. For folks who don't know programming, programs code is written in files. This is just a file. It just looks wonky, but it's just a file with some text. Now, let's just do this. Now, let me just increase the size so that people can see what's happening. Okay, so now this is how this code is written. The program will get some data, like I said, get the data set, divide the data into study data and exam data. That's sort of an example of saying some data to learn the patterns from and then test to make sure that the patterns are right, train the model, and then test how well it does on the exam data. Now, one of the data that we are going to use, now or I'm going to show you that this program does, it is this very famous data set known as iris data set. So let's go here. I'm just going to show you this. So an iris data set essentially is, and again, folks, you don't need to fully understand. What it essentially does is it categorizes species of flowers, I think. And basically, what it does is it takes these four things: length of a sepal, length of a petal, width of a sepal, width of a petal, and then it sort of categorizes them like whether this is iris, this or this or this. So it's a very old data set that was created by somebody that basically has, if I have to like sort of describe, these are the four different things. So it has something is something about the length and the width of the sepal, and something about the length and the width of the petal. And then it tells us like, okay, it will predict, it will sort of say like it's this, or this as the species. So the first thing that you want, so if I want my machine to be able to predict it for different values, what I would do is I would load that data set. So you will see that term here. You don't need to know programming. So I'm going to load that data set. So I load iris in my program. Once I have loaded that data set, I would like to divide it between exam data and study data. So in machine learning terms, that's called training data and test data. So I'm going to divide like it into like training data, test data, and then training data, test data, just so that like I can divide the entire data set. And then once I have divided that data set, I need a learning algorithm. Remember, we talked about like there are many learning algorithms. So in our case, the learning algorithm that we are going to use, I'm going to go back to my code. Yep, is this learning algorithms known as k-neighbors classifier. Again, you don't need to know how it works. I'm just sort of giving you like a picture of how it works. So you need to have this learning algorithm. Now, once I have the learning algorithm, I'm just going to create a model. So by doing this model dot fit, that will create a model. Again, the model is just like a thing been made up of x's and y's. And then once I have the model, I can get the accuracy of the model, and then the model can then be used to predict something. again, you don't need to know I know that a lot of folks here may not be programmers. I don't intend to explain entirely. That's a separate workshop in itself. But the idea is that that's how it sort of all programmers, if somebody is a machine learning AI engineer, this is what they are doing. They are loading the data set. And this is where is it? Where you can do a lot of experimentation. You can see which learning algorithm is the best. Is K neighbors? This is a learning algorithm. So if you go here, you can just go here and like machine learning, and you can find like a full documentation of like what that algorithm does. So you can read through it, you can understand the math behind it, you can understand all of that if you're interested. But then you can keep changing them. This can be regression here, this can be a deep learning, whatever model you want to use. And once you have that and then you train it on the data, then you just get a model which has all those parameters stored, and then that model can be used to predict future values. Now, I will say one thing. I am sure you guys have heard this term that this is a 1 trillion GPT model, or this is a small language model of a smaller size. When they are using that term, essentially what they're trying to say is that that the model has learned. So parameters are an expression of their learning. So the bigger the parameters, the more the learning, the better the model in theory would be. Um, and so like that's how it sort of works. But when somebody is sort of actually doing machine learning, you do need to know a little bit of programming, and you do need to sort of like be able to like test around different algorithms. And this is one, there are many others. And then once you have that, then you score your model. And once you have a good score, I think somebody was asking, let's say 90%, then you try to predict, and then that's when you give it to actual users. And if they like it, great. If they have feedback, then you can improve your model. Okay. I know this was a lot of like challenging technical stuff, but I'm going to pause here, folks. Once again, any questions? What is fine tuning a model? How is it done? Is it also done using Python? I'll answer all three. So, fine tuning a model means giving the model more data for it to make its learning better. So, let's say I use that iris dataset, but let's say tomorrow Swapnil dataset comes along that has different kinds of data, then I can put that back in. So the initial model was already built, but now I'm adding and fine tuning it. What that means is that you build the first model and then you're giving it more data and you're improving that. For doing that, you need some programming language. Python is one of them. You can use any programming language right now. All of them have different ways of doing it, but you do need some way to interact and with the computer, and so you need some kind of a programming language. Python is one of the more famous ones. What is Kunal, are you asking about the k-means clustering thing? Yes, okay. So the K in k-means clustering essentially talks to how many classifications you have. So if let's say you are classifying data into three species, so it's three means clustering. If it's five, it's five means. So it's just the name of the algorithm. Again, I'm not like super familiar with this particular algorithm, but this is essentially that's what it means. K essentially means like how many like how you are actually learning the data. So it's a number for that. Again, I'm gonna share a link on Zoom chat. Feel free to go through it if you want to like read about the algorithm. And Joanne, I will share the recording on Meetup, and I'll share the logistics of it later. But I will share the recording and the slides as well. Um, okay. Any other questions, folks? All questions are good questions here. Specialized or expensive system to get started with learning? Um, Depends. If you are doing deep learning, one second. If you are doing deep learning, right, you are doing like really complex learning, you do need a strong hardware. So like for example, I have MacBook M3 or M4, I forget, and that one has actually like that one is pretty powerful. So I'm able to do very complex learning algorithm. For the simple ones, the regression types or the easier ones, you can use it on any computer. But for the more complex ones, which take a lot more data, which whose learning algorithm is a lot more complex, you do need a stronger system. Let me know, Supernova, if I answered. Okay, awesome. Any other questions, folks? And train models in AWS. Yes, for you can totally train your models in AWS. AWS is somebody else, Amazon's computer, right? So if you can provision a computer for yourself on Amazon, you can connect to it and then you can whatever. So let's say this program that I have on my system, this the same program you can run on Amazon's computer. So you're just offloading your work to a cloud computer. So totally, all you have to do like is to sort of rent a computer from them, get access to it via the internet, and then you can run your workload on it. That's what is happening right now, by the way. Like when you hear stuff like SpaceX is giving its hardware to, I think, Claude to train their model, that's what it means. They're giving their computers, which are very powerful for Claude to train. So you can totally do that on AWS as well. Let me know if I answered your question, Swapnil. I'm gonna wait for 10 more seconds. When I do know what is trained finish. When do I know when the model is trained finished? So that's a great question. So that depends on your accuracy. So what that essentially means is that remember in the program here, right? Let's say I had something known as core. So what you essentially do is once you have trained the model, you test it and then you check the accuracy. How accurate is it in what you want it to do? Now, depending on your use case, you have to see what the accuracy you want. So sometimes you want 90%. Let's say if you are doing something very serious, something like identifying cancer in lung x-rays, then you want it to be way higher accuracy. So you want it to be around like, let's say 99, 98%. So then you have to keep training it, keep adding more data, trying different algorithms to reach that accuracy. But if it's something trivial, 90% is sort of fine, then you can sort of pause there. So it's sort of on you. Having said that, it's an ongoing activity. Once people will use your model, they might give you more feedback, and then you can then retrain or fine tune your model on top of that. Let me know, Joanne, if I answered your question. What would be a good accuracy? Um, Swapnil, that's a great question. That really depends on your use case. Like my personal is like you minimum should aim for 95% because you really want it to be really good. But it can vary. Sometimes like 70% is also okay. So if you are doing it for your own personal project, that's fine. But let's say if you're building a model for a self-driving car, then maybe you want it to be like above 95 and at least 98, 99% accurate. Can you run the example code? I can try. Let's see. I have to see if my system is ready. So you folks are gonna see me live debug. Okay, let's see. I'm not sure if this will run because I haven't actually tested it fully, but we are going to do some live debugging. Hold on. Thanks, Andre, for putting me on the spot, but we shall see. Okay, so let's see. So folks, for folks who are not programmers, this is going to sound very wonky what I'm doing, but I'm basically trying to run that code. Uh, let's see. Again, you don't need to know what I'm doing, but I'm basically like installing the Python systems that I need for actually running creating the model. And then let's see, what was the steps? Okay, yeah, I just have to run this. Let's see. Hopefully it doesn't bog my system, but it might take a while. It's not like it's not it takes a little bit of time for a training like this to happen. Okay, I have a question. What does ChatGPT model use? Are you asking Joanne which model does ChatGPT use? I assume that's your question. Okay. I can quickly show that and then we can go back there. ChatGPT uses what are known as GPT models. So each of these providers have their own models. T stands for transformers, but ChatGPT is this. So if you go here, if you can see all the open, so ChatGPT is owned by OpenAI, and they have a bunch of models. So you can see all the models that they have. They are all different kinds of models depending on what they are good at. You can totally read all about them. They have a lot of information here. If let's say you're using Claude, so Claude has its own models. So you can go to Claude platform, and then you can sort of see like what are the models that Claude has. And then hold on, Claude models. It has to be somewhere. Yeah, you can look at like links like this that can also give you like a broad idea of what are the different kinds of models that Claude has. So Claude also has a bunch of different models that it's working with. So each of these systems have a lot of different models. The ones used by ChatGPT are known as GPT models, and they all have like different capabilities. Like this is the latest one that came out. I think they have a mini one. There's a bunch of them that are available. Let me know if I answered your question, Joanne. Let's go back here. Okay. So when I run the example code, I'll just show you what happens. Where is it? Okay. So you can see it tries to get those 150 flowers. That's the data set. Then it analyzes it. So it says these are the four things that it is made up of. And then it then talks about the species, and then it sort of like says that, oh, these are the measurements, this is the species. Then it studies that model, the model is trained, and then it's apparently 100% accurate, which I'm sure is a bug, so it will not be, but sure. And then if it's a new model, it's going to predict that it's this. So this is how it sort of looks like. Essentially, like you have to sit on a blank screen and wait for the model to do its thing and to give you a response. Let me know, Andre, if that works. Okay, awesome. How to create a dynamic model? What are dynamic models? Okay, I'm assuming the trainer. Okay, I'll answer your Swapnil question in a second. I think Sudhir, when you are talking about a dynamic model, and maybe Peter, it also answers your question. I think what they're talking about is a model that can constantly improve. So here's the thing. All of these models are dynamic models. I can totally have a new data set and I can add on top of this particular model and improve the model. So that whether a model is dynamic or static really depends on how you use it. If you are never going to get human feedback, then your model will never change. But what I can totally do in code is, let's say tomorrow, I realize that, oh, there is a new data set that I want to use. I can again go back, I can do the same thing, divide the data into study data and exam data, retrain the model and update the model. If you are asking question about real-time updates model, that requires a lot of technical and hardware infrastructure for you to be able to in real time update the models. Technically, you can do it from a lot of different ways. Like there are learning algorithms that allow you to do that, but that you require a very strong computer that's immediately picking up feedback and then suddenly improving the model. Let me know, Peter and Sudhir, if that gives enough context. The train test split that was done, does it take random data? Does the training data change anytime every time I run? So no, this is not random data, Swapnil. This is one data set that was created, I think, years ago. So the data itself remains the same, but every time when I'm running, it randomly divides the data. So what comes in study versus what comes in exam changes every time I run the program. One way of making your model better is to run the program 10 times and find the best model. So that's one trick that sometimes people use. Yeah, so whether you have so for having like a real-time update of a model, you need like a strong server. You need a way for you to be able to take a user's input, put it back in the model, and make it run. And so that takes a lot of like hardware infrastructure. You can do it, but it just like you need to have the technical know-how and the ability to have the hardware to be able to do it quickly and in real time. Let's say, for example, model like ChatGPT, when you give it feedback that, oh, I like this response and I did not like this response, it is actually then used in their fine-tuning mechanism, which maybe runs nightly or after every week. And then they sort of take all of that feedback and then they sort of fine-tune the model that they have. What do dynamic models do that as? But what do dynamics do as opposed to? So that's the difference, Patrick. That dynamic models, once you have built, as the user is using the model, and if the user gives feedback, they're able to update themselves then and there. So that's the difference between dynamic and static. But to do that, you need sort of a technical infrastructure for you to be able to take a user's feedback, put it back, train the model, and then give the answer back. So like it requires a little bit more of back and forth, but what models by themselves are always not static or dynamic. It's how you have set up and how you have used it is what makes them static and dynamic. Is how what kind of infrastructure? So let's say let's take the example of this code that I wrote. Let's say I give it some input and it gives me the wrong species, right? The first infrastructure is the code should ask me, is that the right answer? Then if I say no, then the code should take that input, bring it back to the model, and then it has to rerun the model, add fine tune the model, and then it has to give me the right response. So you need that coding infrastructure. It needs to run fast enough so that I'm not like going away from the screen. So you need all of that wiring between the user and the model, and the model should have access to hardware to run sort of the training mechanism, and then so that it's able to give back that answer at the same time. Let me know if I answered your question, Patrick. Oh, sorry, Peter. Um, what algorithm do you use to train the model? That's a very, very interesting question. That's where it's an entire field of research, Joanne. In this one, we are using this one, K-neighbors classifier, which is one such algorithm. You can try uh, hundreds of different algorithms. You can play around and see which is the one that you get the best answer from. There is no one algorithm, there are many. But for this one, it's what's something said, K-nearest or K-neighbors classifier. Let me know if I answered your question. And your dynamic system. Yep, you need a dynamic system to communicate between. Exactly, Peter. Any other questions, folks? These are amazing questions. Different parties in a third party risk management program. Yeah, I'm going to give it 10, 15 more seconds if people have any more questions. And again, folks, learning algorithms and the math of it can be its own sessions we'll do in the future. All of them, nobody can know all of them, but like I'm more familiar with, let's say, regression and less with like something like k-nearest, but there are a lot of algorithms that one can work with. Okay. If there are no more questions, I want to just maybe like quickly chat about it with one thing, just to quickly mention what we are doing next week. So next week, our session is going to be around spec-driven apps with Cloud Code. So AI Saturdays is a weekly thing. So we are going to like be doing another session next week. And I'll share a link on Zoom chat, which is going to be about using Cloud Code for building prototypes. So it's going to be fun. We're going to be building full things. So it's going to be like I'll demo you how to use Cloud Code effectively. So that is one thing I'll share on Zoom chat, folks. So feel free to join us. But now this is more of like an open forum. If people have any questions, we can sort of talk about it regarding machine learning or even regarding AI. Okay, is there a dynamic communication system you could recommend? It's very hard to recommend a system, Peter, without knowing the system that's being built. So it's tricky. If you want, you can just like maybe message me on Meetup about like what are the different things you want them to communicate. And then we can talk about like what are the different technologies that can be used to make them talk to each other. It's hard to like sort of generalize it. Uh, Okay, I have a few more questions. Can we get a recording? Yeah, so I'll be sharing a recording in I think a couple of days, folks. So we'll have that. And no, Joanne, we have not sorry, we don't have recordings of the previous sessions that we share, but we are intending to share them going forward. But I do have access to the previous slides, Joanne. So I'll put them on Meetup. So I'll quickly share it for rest of the folks as well. This is our meetup, folks. This is where you will find us. And so I typically put all the resources here. So whoever was asking for previous sessions, I think Joanne, you were. You can go into the meetup and in the discussions, you can see all the resources, slides and everything that you can use to download and see what happened in the last sessions. So I'll share a link of that. I'll come to you, RP, in 1 second. How do you train cybersecurity models, supervised or unsupervised? Really depends, Swapnil. Sometimes you want them to be unsupervised because it's not always obvious how people are going to try to hack you. So some of these unsupervised algorithms are really good at identifying patterns that humans might miss. But they are also supervised to find common things like somebody trying to do a phishing attack or somebody trying to do like a DDoS attack. So both are used depending on the use case. I have RP first and then I'll answer the other question. Yeah, RP, go for it.
Thank you again. Since I don't have coding experience, am I to understand that next Saturday's session will be on coding?
It will be on how do you use an AI tool like Cloud Code to write code and to build a software. It's fine. It's okay to attend that even if you don't know anything about coding because most of the coding will be done by Cloud Code. But for you to actually use it, you will need a Cloud Code subscription to actually be able to do it yourself.
Okay, because I have Claude Pro.
That
That was
should cover it for you.
okay, good enough. All right, thank you again.
Yeah. No, thanks, folks. Amazing. And I have another question. What is your take on AI might take your jobs? It might. I my take is that so my take was honestly is that I have two takes on it actually. The first take is that I think that I want to my approach to this is it can happen depending on which field you are in. Like from my understanding, and this is just from my reading, if you are in a field like customer support or any of that, there is a higher chance of it being automated away. Whereas there's a lot of like physical fields that AI has not. We don't have good physical AI yet. So that's there. Like I think there are some fields that are more impacted than others. In the long run, I feel like I don't really know where it will go, but my approach to it is to keep trying to learn AI and to keep trying to like sort of like understanding where the field is going because I do think there will be a requirement of a human in some shape and form, but what that human requirement is that is going to be a tricky question. How the $20 a month subscription would that be enough next week or so? I need no. I also have the $20 a week month. You guys don't actually necessarily need to even do that. You can also just get Claude API credits as well, but $20 a month is fine. That's the one even that I am also using. Um, and yeah, hospital admin is another one. There are parts of it that are getting automated, so it really depends. And thanks for the kind words, folks. This has been an amazing session. I do want to quickly share if people want, do follow us on LinkedIn as well. We do put a lot of our resources and stuff there. Um, but I'll give it a one last call, folks. Any other questions? Yeah, if you spend it on one day, good. Yeah, Michael, same here. I am able to, like, I usually just take a break when my $20 subscription runs out, and then I come back to the problem when it resets. Yeah, Cloud API credits also work. You can just buy like $20 or $50 of Cloud API credits, and they can also be enough for you. Any other questions, folks? This has been amazing. You folks have been amazing. I'm learning so much from your questions and just the stuff that you are bringing up. How much are they? Sorry, Peter, what are you Claude credits? So Claude credits is based on your amount, so you can buy $20 worth of credits. Okay, cool, folks. This was an amazing session. Thanks for joining. This was a lot of fun. Please join us on Meetup. Please join us on LinkedIn. Come for the next week's session. Feel free to leave us a rating on Meetup. That really helps. But thanks, folks. This was amazing. Thank you so much, everyone. This was a lot of fun. And we shall see you next Saturday. See ya.